Okay, you've got a sheet. It's for March. It's worth 12 marks towards your term mark. Everything we do in future is for marks. And we're going to do a little experiment. Will it work? Won't it work? I love science because you never know. Well, you hope. We scientists, if we can call ourselves that, live in hope. Okay, and I'm not going to tell you the answers. You've got to listen. So if I say this is a gas jar, I'm not going to really emphasize it, but this is a gas jar. It's one of the answers. Why is it a gas jar? Because it holds gases. So here I've got it. Sorry, whose scissors was that? I owe you a scissors. I'll get you another scissors. Sorry about that. They don't make scissors like they used to, do they? Okay. In the gas jar, we're putting a candle. Whoa. So there goes our candle. I'd like it to stand up straight, but if it doesn't, I'm cool with that too. Okay, it's going to stand crooked. So here we've got a reaction. This is a common reaction. We're going to take a candle which is carbon, and each carbon has got hydrogens on it. So we're burning wax, plus oxygen. Now you remember oxygen's got two hooks. So we're going to take the candle, burn it, add the oxygen, and create something that's going to be new or known to you. So let's just tell you what we're going to do. We've got carbon, hydrogen, plus oxygen, and we're going to break up the candle. Now this is what's happening to the candle. The candle's getting hot, it's heating, and it's disintegrating into carbon and hydrogen. Okay. Does that make sense so far? That your candle, which consists of carbon and hydrogen, is breaking. They don't even make glass like they used to. Look at this gas jar broke. My word. Okay, video, just have a look at that. We're working under difficult circumstances. Like I said to you, I like science. It's a bit unpredictable. You see, glass, if it heats on one side, gets hot, and then it expands on that side, it contracts or keeps cold on the other side. But I thought this kind of glass, they made it out of quality stuff. Sorry, my mistake. Okay, so let's just finish. So now we take the carbon and we add oxygen. Now let's just do that. We take carbon, how many hooks has carbon got?
1, 2, 4.
It's in group 4, 4 hooks. Okay, 1, 2, 3, 4. There you see it, 1, 2, 3, 4 to the hydrogen. And now we're going to unhook the wax and join it to oxygen, which has got how many hooks? 2. And there you go. And this is CO2. Anything I've told you so far that's difficult?
No, sir.
All makes sense. Now we're left with a few hydrogens. So let's take the hydrogens and let's add oxygen and hydrogens. How many hydrogens do I need? So I take oxygen, 2 hydrogens, and we get H2O. So we're going to burn a candle, plus oxygen goes to form CO2 and H2O. Okay, so there's one reaction. All happy with that so far? Happy with that? Okay, because we're going to ask some questions on that. We're going to ask some questions on that in a moment. Now, the next thing I need Ladies, if you sit at the back and chat, I'll just chuck you out. And then you can do the practical outside for what you can see. Okay. Now, let's do which C? KMNO4. Did I show you before that we mix this with glycerine and we get that explosion? Did I show you that? Okay. So we're going to take the same stuff. We're going to take the same stuff and we're going to heat it. So you see there, KMNO4. Now I'm not using my own because I'm going to use a lot of this stuff. Do you recognize it as the same stuff? More or less? Okay, that should be nice. Whoops. Now, I need stopper. I don't have a stopper, so I'm going to use nature's stopper. This is for mops. Okay, there. That'll stopper it nicely. So the stopper is to not let the gases out. Okay, great. Then I'm going to take I hope my video can show it. I'm going to take our stopper, which is actually a carrot, and I'm going to try and drill a hole in it for this plastic tubing. So, whoops, so there. As I say, I don't try this, we just try it here because it's much more fun that way. Okay, so there we got some, and this is called a delivery tube. Okay, so we've got a stopper and a delivery tube. And now any gas that's formed, we can put it onto the candle and see what happens. Unfortunately, my gas jar is broken a little bit. Let's see if it works even that way. Okay, so this is reaction number one. We're taking KMNO4. So K's got one hook. Permanganate, MnO4 has got one hook. And this is called KMNO4. And we're going to heat it. Okay. I want to see what happens. Are you interested to see what happens? Okay, let's get everything flammable out the way. Now, you saw what happened to the glass. So let's start heating it just gently and get everything nicely warm before we... You see, if we heat it on one side, it's going to crack this. Because I presume this is also pretty poor quality glass these days. Okay, so now it's getting a bit warmer. I just want to see what's going to happen if I start heating the potassium permanganate. Can you all see? Okay, so let's just see if anything happens when it starts to heat. So now I'm concentrating the heat on the potassium permanganate. I don't want it to crack, so I'm trying to distribute the heat. I just want to see what it does to the flame, if anything. Do you see what's happening to that flame? Does that flame look better or worse? It's giving off a gas. Do you see how the flame has turned like white? Look at that. Now, just let's blow that out and let's just see. I just want to see something. No. Let's get a piece of string. Let's see if this works. So we get a piece of string, we blow it out. I'm going to hang the piece of string. Now it must just glow. So let's get that candle out just for now. Okay, so you see there's a piece of string in there just glowing. Let's see what happens, if anything. Now, you know why teachers hate doing practicals? Because sometimes what they want to happen doesn't happen. But I don't mind. You see what's happening to the string? Okay, let's do it again. Watch what happens. Now this is a test for oxygen. It tells me that this is giving off oxygen. So the test is, if you take a glowing piece of string and you heat it with oxygen, it bursts into fire. Where does the oxygen come from? The KMNO4. That's where my oxygen's coming from. Okay. Now let's try another reaction. I actually used the wrong, so let's try reaction number 3. I actually used the wrong. Now this thing here is called a test tube. Maybe I can use the same stopper, so I don't have to cut another stopper. Where's the leftover bit of our scissors? Okay. Now, like I say, I should have possibly used that, which is called a flat bottom flask, for what I'm going to do next, because next I'm going to take some bicarb and some vinegar. Now, this may be a reaction that you know. Bicarb and vinegar. Let's light this again. There's bicarb. Here's vinegar. And I must get ready to do this quickly. So what is this here? Bicarb and vinegar. Now let's just see what that does to the flame. Let's put a bit more vinegar in, but maybe it wasn't enough. Whoa! Now we're not supposed to drown the flame, but this gas that's given off is carbon dioxide. And carbon dioxide will smother the flame, because now the candle can't breathe. So that's reaction number 2. I guess that wasn't a perfect demonstration, but to get, it gives off this carbon dioxide, and the carbon dioxide will put out our flame. Now, to put out the flame properly, let me tell you what we've got to do. We actually need a shorter candle. Do you know what? We need a shorter candle because the carbon dioxide will fill the jar, and then it's as if the candle drowns in carbon dioxide. But this jar is broken. Let's just see if is it worth maybe doing it again just with a shorter candle? Let's try. Come on, you were burning. Okay, let's slide it gently down there. Okay. Let's get some bicarb. Now what I'm going to do, add some vinegar. And I'm just going to let the gas run into the jar if possible. Just like I would water. You see, now you maybe see why that should have been done in the flat bottom flask. Because it fizzes out. Let's just see if it produces enough CO2 to put out the candle. A little bit more CO2. It doesn't matter that the water goes in, it's just important that the gas, the CO2 goes in. Do you see how poorly that candle is burning? So the CO2 is putting out the candle. Now when we take this away, it seems to come back a little bit. Next time I'll remember, do that one in here so that we can get a lot of fizz going. That girl over there. Take yourself out. That girl over there. Stick it from the back. Take your sheet. Stand outside. So you know why we do it in this? So we get the fizz here, and then we can get a lot of fizz. Stand over there, and you can fill in your sheet. It's for marks. Hand it to me when you eat. Okay, now let's get our final reactions. So, what have you got to answer? Draw bonds for KMnO4. Can you draw the bonds for KMnO4? There it is on the board. So do you see how we join K and MnO4 together? Okay, so there's your first answer. All the answers are there. So you can draw it right next to where there's a tick. Each tick is where you're going to get a mark. How does K and MnO4 join together?
So we must write the next one.
Right next to it. Like this is how you're going to draw K, MnO4. That's line number 1. Now I know that you can all join oxygen. How do we join oxygen? That's number 2. So number 2 is, how do you join O and O? With the hooks. So look how many hooks has oxygen got? 2. Okay, join them together. Exactly. So your first one, number 1, would look like this. So that number 1, I'll give you 1 more. 2 looks like that. Now 3, how do we hook O and H? How do we hook O, which has got 2 hooks, with H that's got 1 hook? So you know exactly how to do this, we hope. Let's see. Do you know how to do it? Do you know how to do it?
Yes, sir.
Okay. CH2 looks like this. CH2. So that's what CH2 looks like. You will see that some of them have got hooks and others not. Do you see that CH2 has got 2 extra hooks? And then it's hooked hydrogen.
So must write it again, sir.
That's fine. Does everyone understand CH2? CH2? So you got it all? Okay, that's CH2.
Sure.
Yeah. Okay, the next question. Question number 5. Draw bonds for vinegar. Now you know what? I have to help you here because you don't know the structure of vinegar. So let's draw bonds for vinegar. So 4, you know how to hook up the C's plus H's. 5, vinegar. CH3COO. Draw the bonds for vinegar. And then an H. And that is vinegar. If you don't mind.
So,
That's vinegar. CH3COO and then a hooked H to it. Remember, hooked H has got one hook, and this is called bicarb. Sorry, this is called acetate iron, but don't worry about it. Just draw. You will get your mark. Now, what does bicarb look like? Number 6. It looks like this. C, I'm going to draw it here, CO3 with 2 hooks. There's Na, there's H. Can you hook that, Na and H to the CO3? And then you've got your bicarb. Now, do you guys see how well this flame is now burning, now that the CO2 has been gotten rid of? You see, this is the way the flame will burn. But when you start adding your CO2 into it, then it comes almost die. I wanted it to die, but it refused to die. Because we didn't probably use the right equipment. But the next class will get the right equipment. Got some salt. But there were salt and iron checking on that side. Just going to fix my biscuits. Do you want hummus? You could take a step. Yeah, that's fine. Okay. Just poor abused scissors. Here. Okay, perfect. Thank you, sir. Okay, so can you hook this together and get your bicarb? Number 6. Okay. Now label 1, 2, 3, and 4. They took the key back to Mr. Young. He's already started. Okay, what is this thing again? Okay, and what number is it? There you go, there's your mark. Does anyone know what this thing is called? A test tube. Okay, you figure out which number it is. At the bottom here. So you see the labels 1, 2, 3. Which of those is a test tube? What is this caret in place of? Okay, so there's your stopper. And when this thing is called a delivery tube. I'll write it down. So we got a stopper, a test tube, and a delivery tube. Well, that you can easily get yourself, right? Just check on the sheet what is number 1, 2, 3, and 4. The label. You see the space here? What is label number 1 right over here? Yeah, at the bottom. At the bottom. Whenever you see a tick, that's where you must write something. Right? Now, which reaction made the candle burn bright?
Sir, number 6 must be good yourself.
Rewrite those, they can just rewrite the Guys, if you make a mistake, I don't care. Just stay calm, rewrite.
So much right. The reaction you
So what about number 4?
This is for my next one. Okay, now the last 2 marks. Which reaction, 1, 2, or 3 made the candle burn brighter? I can't give you a new one. Did you get one to start with? Don't worry about it. I'm more untidy than you, guaranteed. So I'm not going to penalize you for being like me. Okay. If you remember correctly, you will know which reaction made the thing glow brighter. You stick with that answer. And then which reaction made the candle glow dimmer? Was it 1, 2, or 3?
2.
You write that there. I don't want to mock myself. I want to know what you learned. I think it's warm now. Should we just try something again? Let's just, seeing as we've got a bit of time, let's not throw this potassium permanganate away. Let's just pour it into a test tube. Okay, this is how I should have done it, but I forgot. I haven't got any water, so let's put some bicarb in here. Now we can get a massive amount of bicarb. Now let's see how that works. Okay, massive amount of bicarb coming out. Do you agree there's a massive amount of bicarb?
Yes, sir. Yes, sir.
Okay, I say, and I hope this camera picks it up, that when I throw the vinegar into the bicarb, you see how well it's burning. You see how I put
That's
the...
supposed to happen.
Exactly. Do you see how the carbon dioxide put the candle out? Because we now had enough CO2.
So there's number 1.
2, 3.
Hang on, let's look at number 1. Number 1 has got KMnO4. Remember I said this blue stuff is the KMnO4. Or purple or whatever, I'm colorblind. What color is it? Okay, that's the color. But this is reaction number 3. This here with the bicarb is reaction number 3.
No.
We've just done reaction number 3. Look what it looks like.
Then number 1 is brighter. So
Has got 4 hooks.
what about number 1?
But we only hook 2 hydrogens on it. Now let me tell you why. So we can hook it to more carbons. So it's a whole long chain of carbons. Does that make any sense? So a candle is actually this. Do you see that each carbon has only got 2 hydrogens if they hook together? Do you see that? That's why I say a candle is CH2 except for the end where it's got CH3.
So the two hooks are carbon.
They left. Yeah. Any questions? Name on it? Okay. I'm going to give you a little test tomorrow when I see you next. Okay, let me tell you what it's going to be on. Do you know how you hook things together? So this is the whole test. If I give you 2 things and I tell you how many hooks it's got, can you hook it together? Anything with 1, 2, or 3 hooks, I'm going to give you how many hooks it's got, and you've got to say what its formula is. So, for example, if I say to you, carbon's got 1, 2, 3, 4 hooks, and oxygen's got 2.
So you put another oxygen to
Can you put another oxygen and write CO2?
Yes, sir.
So you'll get a mark for, right, hooking it together, and a mark for the formula. So that's your little test coming up. Any questions? Next time I see you, can you hook things together and come up with a correct formula? Do you remember that simple cheap way we said of hooking the formula? Swap the hooks around with the different chemicals. Does that make sense? And then make it the lowest number possible. I'm going to come from. As you go out, I'm going to collect each one, make sure your name and grade is on it. Now I'll mark yours for you. I'm sure I trust you.